Good evening, ladies and gentlemen. My name is Donal O'Callaghan, and on behalf of the Chemical and Process Division of Injuries Ireland, I'm delighted to welcome you all to our first in-house 2024 event. The topic is cybersecurity in a connected manufacturing environment, and we're delighted to have Damian White, who's CTO of DataLogiX, to be with us here and to give the talk. Just to say something about cyber attacks, before I came here tonight, I read that over 70% of Irish firms have been hit by cyber attacks in the last 12 months, which is an unbelievable figure. And they say that in line with Belgium, the Netherlands and France, the most common point of entry for hackers was a corporate-owned server, while the most common outcome was a financial loss due to payment diversion fraud. So obviously it's something that we all have to take very, very seriously now. And this report, it's a report done by an insurance company. They said that Ireland's again more likely than any other country to pay a ransom at 77%, with phishing, not fishing with a rod, but phishing, overtaking unpatched servers as the most likely entry point. So obviously it's a big item on most companies' agendas these days, and obviously security of same against cyber attacks is really where a lot of companies are investing money at this point in time. So I just go into maybe say something about Damian. I know, Damian, you've got a certain amount of bio on your presentation, but Damian is an expert in the field of securing operational technology networks. He's over 25 years experience working closely with multinational pharma companies. You possess in-depth understanding of the unique challenges faced by industries such as life sciences. DataLogiX specializes in securing OT networks and used by global organizations. So I think I'll hand over to you, Damian, and maybe you can give us your words of wisdom, I'm saying. And just before I do, at the very end, we'll have a Q&A session. And basically in your chat box, for those people who are remote, in your chat box, there's a Q&A session. And if you just, or section, if you just put your question on that, and one of my colleagues here will note your question. Thanks very much. All yours, Dave.
Thank you, Don. So good evening, everybody. And I'm Damian White, the CTO of DataLogiX. My colleague Dirk Remen, he's the CIO. He's here, or CEO, sorry, Dirk is here as well today with me. And the topic today is cybersecurity in a connected manufacturing environment. But let's start the process. Donal mentioned some very, very interesting statistics there, but I want to start the process today talking about cyber in general. But firstly, I just go through a quick introduction to DataLogiX and where the company came from and where we are. So our background is IT, very strong IT, but because of the geographic, we're based in Cork. We were surrounded by multinational manufacturing industry and organizations that were built on the manufacturing process. So in the late 90s, early 2000s, we were actually building IT infrastructure for manufacturing without even knowing really what it was doing, because it went from what all you guys would be familiar with, the old process field, to now a connected field where things started getting a connection and merging with the IT world. So as our business evolved, we actually in the mid-2000s probably realized that all of our POs from multinational pharmaceutical were coming from engineering groups and not from IT. At the same time, IT became more of a commodity where every laptop was the same, every server was the same. But in the process field, we're finding that even two manufacturing plants, the same, at different parts of the world with the same organization, have different nuances. That means they require a different deployment. So we turned into what is now called OT, or operational technology. And I'll go through that in a minute where that came about. But it wasn't defined until 2011. But we had been working in the OT space for long before that. So what I want to do today is I want to go through, first of all, cyber, how cyber relates, and specifically then get into how cyber relates to manufacturing. But to start with cyber and cybersecurity and threats, Donald mentioned phishing a while ago, and cyber could be something as simple as the toll you get that says, or the message you get that says you haven't paid your toll at the M50. Click the link, enter your credit card details. They're looking for one of two things. They're looking for you to pay the money, or they're looking for you to enter your credit card details so they can use it. That's number one. Number two, you get the email that says your product is due for delivery, customs fee. Again, same thing, click the link. That's very much aimed at the personal space. How can I get $10 out of you, 15 euros out of you, or get your credit card so I can max it out? As you move up to the business space, what you get is people being a bit cleverer to say, can I send a dummy invoice to this email address in the hope that it'll be paid to a different bank account, things like that. Then when you start up in the game completely, you get into ransomware and things like that. And ransomware at a very basic level is, how can I encrypt all of your files and then make you pay over a ransom, just like a kidnapping, to get your files decrypted? Again, predominantly happens in the IT space, very much rather than the OT space, but accidental infection into OT happens very regularly because the split between the IT and the OT organization isn't good enough. And again, that's something I'll cover as we go through the presentation. When companies were faced with ransomware, to deal with it, they started looking at things like a very good backup scheme. Let's make sure I have a good backup so now I can recover to where I was last week or yesterday and not worry about paying the ransomware. So now cyber criminals said, let's up the ante here, and we'll say, now I'm going to steal some of your data as I'm encrypting it, and I'm going to threaten you to say, let me leak that data online. So now I have intellectual property belong to, again, if it's a global pharma manufacturing company, or in the case of retail and people dealing with the public, it's, do you have names, addresses, GDPR information that you could leak online? So again, it isn't enough to say I don't have to pay the ransom because I can get my data back. Now I need to pay that ransom to stop the information spreading online. So that's how, let's say, cybersecurity has evolved from personnel to business. And then when you go into the world of manufacturing, you look at the endless possibilities, where the Florida water group were actually compromised a few years ago, where the threat is, how could I potentially say I've poisoned the water just by taking over the manufacturing or the control system that runs Florida water, to say, maybe I can change one of the values to say something got out in the water is reporting okay, but it actually isn't. So again, these are all the possibilities when you take that in, but the end goal is, just like a bank robber back in the day, how can I get money from a multinational pharmaceutical company by threatening the supply of their product? And that's by either modifying their product or stopping them. And again, what we see in the likes of the pharma industry is, if you've got a guaranteed supply where you've got people dependent on your drug, the worst thing that can happen is you can't meet that supply, because that puts you at risk straight away. And again, as we go through this, what you'll see is that the more of these systems that get connected, the more they're open to cyber, and they need to be properly protected. So just in terms of general cyber, this is just some of the events that have happened in March 2024. So this is just alone last month. So the number of events that you see every year is frightening. And, you know, they can be very simple, but well-known organizations. So the International Monetary Fund, who I would imagine have very, very good cyber practices, had a number of email addresses compromised where people had access to their internal systems. You know, you had Fujitsu, or one of the largest manufacturing companies in the world, infected with malware, which was reporting back out to, you know, they're not even sure where it was going. Crinetics, are they're a big manufacturing company, caught by a ransomware. And then, you know, the real scary one is hackers having breached a nuclear facility in Israel. And that's where we're into really scary territory, where, you know, the possibilities, if they're in that nuclear facility and have access to potential reactors, what could they do with that? What sort of, you know, threats could they make? And we're not just talking here about, you know, a kid in his bedroom with a PC anymore. We're now talking nation states who are looking at how can they gain political advantage and everything else. So that's where the world of cyber is. And again, just to repeat, all of those incidents are just ones that I took a sample of from March 2024. Guaranteed at the end of April, you'll have the equivalent again with different organizations. And, you see there one of the figures at the end of 2024, the estimate is that the cost of cyber attacks on the global economy will be at $10.5 trillion. And that's interrupted process, ransomware paid over, the cost of labor to recover and get things back to where it's working. So that's where it's going. And again, back to what Donal said at the start, things like phishing. The next level of phishing attack is social engineering, to say, how can I target somebody from that organization to get access to their email address, to then give me access to their PC, which then gives me access to, maybe it's something financial, or maybe in the multi-billion-dollar industry that is pharma manufacturing and med device and all of those things, how can I get access to something which gives me access to the product and hold that company to ransom because of that? And again, cyber warfare, obviously when you see now what's going on between Ukraine and Russia, when you see the Israeli conflict, that all of these things, and even that Israeli nuclear facility, maybe that's a political reason to take that over, but it opens all those possibilities. So just very quickly then to get into what is operational technology. And what we saw with operational technology is things that were very much a physical process became a digital process. So, you have IT over on the left-hand side, which is your laptop, your Teams, your email, all of your, let's call it, corporate systems. And then on the right-hand side was where you had your industrial control system. And when those two worlds started colliding for a number of different reasons, it was because we see things like quality in manufacturing, where it isn't good enough to say, I decided I'd start the line at 701, maybe it was 703, maybe it was 704. Now, with everything's digital and everything is being recorded, you have that guaranteed quality, guaranteed safety, identification of who, what, where, when, who did it, why did they do it, what did they do it for, recording all of that information. And that's where these worlds get together. And where DataLogiX fit in specifically is that because we're coming from the OT side, IT side, with an understanding of how those control systems worked, because we got that over the years, we can now go into a site and look at the applications and processes that they have and map that to how best your network should look on the right-hand side, using the best practices from the left-hand side in IT. Otherwise, what you'll get, and again, I'll allude to this as we go through, when you come from the right-hand side, the left-hand side IT systems into OT, you assume everything is the same. You assume everybody's going to need access to the internet. Everybody's going to need access to the email server. Everybody's going to need access to areas that they don't need in IT. Because in the IT world, you don't really block anything from anything. When you're at the airport, when you're at home, when you're in the office, you want access to the same systems regardless of where you are. So, the impact then of a production stop of critical supply chain is, what happens if? And OT systems, where they differ from IT, is they've got a lifespan of 10 to 15 years. So when you buy something in the manufacturing world, it's never bought for its IT capabilities. It's bought because it's a critical part of making the product, making the process. So the IT is only secondary. And what happens is when it comes in, it doesn't fit the corporate standard. So you've got to figure out, well, what do we do with it? If it's got a far longer IT life cycle, you can't just throw away the piece at the front if it's attached to something that's critical manufacturing, because it all came from the vendor. It wasn't an off-the-shelf PC. It wasn't an off-the-shelf switch that came with it. So a lot of the time, you'd see on your own personal PC or your work PC, patching happens automatically. The PC reboots. You may or may not have saved your data, not the end of the world. 24/7 critical manufacturing or a lab doing some analysis, you can't just reboot in the middle of a batch and say everything will be fine. We missed 3 or 4 minutes, but it's all going to be okay. So, that's again where the worlds don't meet. So applying cybersecurity techniques then from IT into that OT or manufacturing world, it comes with huge risk, because what happens if it doesn't come back on that reboot? What do we do with the product that's in the incubator or the tank or whatever that is? So, the other thing is that just because it's a legacy system that's 10 years old or 15 years old doesn't mean you have to exclude it either. It doesn't mean you have to go and replace it. The PC may cost $500 to replace, but what it's attached to could be many hundreds of thousands up to millions of cost to replace that, just because the PC is the front end. So, the big risk once you connect those systems and once you moved from that analog world into the digital world is security, because you connected it to get functionality, but the minute you've connected, you've brought all of that risk onto yourself. So, external factors from outside your organization, outside your four walls, outside your country, and even from the internet can potentially stop production. It's very rare that we would see production systems that are directly accessible from the internet, but it can a lot of times be very easy for somebody to just via 2 hops get onto a corporate PC and then from there cause the outage in production or manufacturing. So I always use an example of something like a tank here. So this is a Siemens Simatic HMI, and its only function is to fill and drain that tank. That's it. So the operator comes up, he hits fill, the tank fills, he hits drain, the tank drains, and that's essentially all it does. So again, in an ideal world, you might leave that disconnected, wouldn't do anything else. But in reality, that's a Windows machine, as you can see down the end. So because that's a Windows machine, it functions exactly the same as your home PC. It's exactly the same as your work PC. Comes with an internet browser, comes with services that are there. Everything that it would need to access the internet or be connected is there. But again, the bit that's lost on IT people coming into the industry is they don't realize that its only job is to fill and drain that tank. That's all it is. But what it also brings with it is, now that that tank is being filled and emptied, people want to connect that up so they can start getting analytics, for example, to see how often does it happen, how efficient is it, can we get AI to look at that and see, is there a better way to do it? Look at the data of how often do they fill it, how often do they empty it, and what does that mean? How can we bring that into a manufacturing execution system? So now there's a recipe around the filling and the emptying of the tank. It's attached to a bigger process with potentially a batch record attached to that. Can I get historical information? So, historian, and there's a lot better qualified people than me to sell historian products, but to my mind, what historian is that if you're reliant on some type of a drug, you want to know that that product is guaranteed to be made in exactly the same way within the parameters outlined by the FDA every single time that you take it. And if there's an investigation, you want to go back and say, on this date, 11th of April, the product was made in exactly the same way. It wasn't the guy drained the tank because he was heading for his tea break in 5 minutes. It's all according to the right process. So that's why these systems went from being standalone to now being connected together and connected to potentially the outside world. OEE, again, is something that we see for efficiency, to say in lean manufacturing, how can we look at these systems and say, get that information to say, is there a more efficient time or date to do it that, depending on air temperature and everything else, is there a better time to actually do that facility? And again, that applies to all manufacturing, not just the tank. So, but, the question then is, how can we connect up these systems without necessarily exposing them to the world? And that is the essential difference between the IT and traditional IT and OT as it applies to manufacturing or the process sector. So there are some very good standards around how to do this. And one, the first one comes from the ISA, the Society for Automation, and they have a series of standards, 62443, which are very, very detailed on how you should run your industrial control system. And then the National Institute for Standards and Technology, they have guides for how you would deploy an industrial control system. And both of these guides are very, very good in terms of how you should have a difference between your IT versus OT, how you should have integration between those, and how you should, let's say, leave the legacy system online without necessarily exposing it to the world. And these are two very detailed standards, but very, very applicable to this world. The third one, which is one I'm going to probably get into a lot today, is to do with the NIS2 directive. And the NIS2 directive is a European-wide directive that's coming this year, in fact. And that now changes the goalpost for responsibility in terms of a stop in manufacturing. So it now actually brings into legislation the onus to continue supply on critical infrastructure. So now if you've got somebody who's performing a critical function, again, whether that's energy or service to within the industry, but also within critical manufacturing, there's now an onus on the company to actually ensure the continuity of supply. So you will have to demonstrate that you did take all reasonable measures to make sure that your manufacturing continued in the event of a cyber attack. You know, at a very base level, if you were producing with direct connection to the internet and you got hacked, then production stopped, you can't continue supply. If you're considered a critical environment, you would then be on the hook for, well, why did you not follow the standards of 62443 and NIST, which would clearly state you wouldn't produce when connected to the internet. So very quickly then, between the NIST guidelines, that's the NIST NIST guidelines, and the 62443, what they define are the levels of the production process. And down at level 0 and level 1 and 2, this is essentially where your production happens. So like we just saw a minute ago with the tank emptying and closing, level 2, this is according to what's called the Purdue model. Level 2 in the Purdue model is where you would have that PC controlling the tank. 1 and 0 is where the data is exchanged into the tank to say, open that valve to empty it, close that valve and turn on the tap to fill it. So down at that level 2 is where production actually happens. If you have an outage at that level, production will stop in minutes or seconds. So, you know, at a very basic level, if that valve controlling the tank was to stop for whatever reason, then, you know, if it blocked, the tank stops emptying. If the tap doesn't open, immediately it stops. The production process stops. As you go up that level, if the PC, for example, stopped functioning, then after I'd hit drain the tank will continue to drain even though the PC has stopped. So you will survive that extra few minutes. You just won't be able to fill the tank next time around. And again, as you drive up the levels and you put things like the manufacturing execution systems and the historian and recipe management and things like that, now you should be able to increase your life cycle by saying, well, now I still have the PC controlling the tank, but maybe I can't download the next recipe, but I can complete the batch that I've already downloaded. That batch might be minutes, might be days, might be hours, but if you lose your level 3 system, as long as you have the ability at level 2 to keep going, then you've bought yourself that bit of time to get through the process, at least some of it. And then higher up at level 4, which is where your critical or your IT systems are, you really there should be only looking at order information, email, you know, things that are not critical to production, that it could survive multiples of, you know, days, weeks, months, if possible, without it. And, you know, in an ideal world, if you had a global outage in IT where, you know, the company were hit by ransomware, malware, something that would actually take out their entire system, could you continue manufacturing from, at best, level 3, at worst, level 2? And that's what's really important about these standards, to help you have that divide. And for that divide to work, you really can't have your level 2 systems depending on services or talking to services in IT at level 4. So again, back to the tank, The only thing that PC needs to do at level 2 is drain and fill that tank. It's the only job, it's the only show in town. And the systems at level 3 that take information from it, how can you exchange that information between the levels without necessarily opening it up? Now that all of that, there's a lot of information in the standards around this, but at a very high level, that is how you implement your security, and making sure that somebody compromising level 4 who comes in through the internet doesn't have easy access to the PC at level 2, so they can, drain and fill the tank at the wrong time. So having that access for convenience, we see quite a lot in the IT world where everything is done remotely now. You want to get everything from your office. We don't really see people operating plants remotely. You would still be in the plant to operate the plant. So that remote access for engineers should really be a convenience thing. And that's, if it's not available, not the end of the world. The operation of the plant should still happen. So that, as I said at the start, this is what's called the Purdue model in terms of where things are placed. But the traffic flow between the Purdue model is really important. And what's happened now is that in the world of AI and analytics, a lot of people have blown through this model where they've said, well, I want to get data from level 1 from the tank so that I can do a preventive maintenance to see how many hours before it's going to fail. And while that is important, to me, how you collect that data is actually more important, because collecting that data and sending it to the cloud for analysis is no risk. Allowing it to come back in and modify the production process, that's where the risk is. So the secure exchange of data up through those levels so that the analytics can be performed offline, and then any changes actually come back through the form of a notification to say, go and change that. And obviously in a change control environment, you don't want automatic changes from the cloud coming in to do that. You want somebody to be notified, make that change, approve that change, and go in and get it done. So I'm just going to go on now in terms of that NIS2 directive, and there's a lot of information on this. This is really just an overview of what the NIS2 directive is. And it's essentially, its predecessor was European legislation for critical infrastructure. And now basically it's been expanded EU-wide to look at what the impact would be for critical systems going down, and making sure that according to the legislation that impacted organizations have thought about cybersecurity. They've thought about their infrastructure that's needed to keep that critical infrastructure operational, and to make sure they at least go through it rather than say it was best effort in terms of how everything was connected. So there was a previous NIS legislation, but this has now come into more impacted sectors. It was energy and gas and things like that. Now it's gone into chemical manufacturing and a lot more areas. A lot stricter requirements now on what you have to meet, and far worse repercussions. And in fact, it's only 188 days from now, 188 days, 19 hours, in fact, before you need to be NIS2 compliant. And the starting point for NIS2 compliant is the industries that are affected or that are in scope of NIS2 actually need to be registered by October this year, 25 or 24. So again, that's just very quickly showing NIS1, that was the industries in scope. NIS2, you can see, is quite a lot more. And what that means in terms of the original sectors were healthcare, digital infrastructure, transport, water supply, digital service providers, banking, financial, energy. But now as you come over here and you look at, again, the industries that I work across, you have pharmaceutical, R&D, critical med device, food producers, processors, manufacturing critical products, again, PCs, electronics, postal and courier service and things like that, but also wastewater and chemical manufacturing. So it's a significant change from what was there. And, I did hear somebody recently discuss this, that it's actually quite similar to what was considered critical manufacturing or critical infrastructure during COVID. So at the time when people weren't able to travel, industry was shut down, anyone who was deemed critical was able to continue that process. And it is a very, very similar list, because at the time we were seeing guys in food and beverage who again were able to continue producing. So now it's the same rules that are going to bring them in scope of the NIS2 directive. So just again, this is only something I've seen recently, that within Ireland, it will actually take it from 125 entities in scope of NIS1 to now over 4,000 entities under NIS2. So that's a huge game changer in terms of the industry and now who's responsible for it. And again, one of the things we would ask a lot as this NIS2 directive comes in, and it is a phased implementation. It's not that people are going in handcuffs in the 1st of November, but during this phased implementation, the question is, if you're hit by a cyber event, who's on the hook? So who's going to have to explain why we stopped production? So now you have guys who are head of plant, guys who are head of manufacturing, guys who are the senior engineers who are responsible for the process control system, who previously had little to no involvement in the IT or the cyber side of the house because it was done for them. So when that now is being done for you by somebody who's wearing an IT hat, the onus is on somebody to say, well, does that person know what they're doing, or did they just connect in the PC that empties the tank with a piece that's there?
Who's actually going to be policing it now?
Yeah, it's a good question, but it's coming next, in fact. But it again, because it's an EU-wide legislation, we have seen very similar things with finance, for example. So it will become into the let's say it'll be legislation in the law for someone. There's a group called the National Cybersecurity Centre in Ireland already, and they're already advising the government on how this works and how this will be. The policing bit comes next, but in terms of the timeline, October 24 is the deadline to comply with the NIS directive and at least be registered, and then April 25 is when the member states will establish a list of their essential and important entities. So you do have 6 months from there, but it's actually, within government to say, we've collected these 4,000 entities in scope and here's all the detail. But from there, it's 27 before they'll actually review it to see, now we're going to enforce it. So it is going to take some time for somebody like the National Cyber Centre to be able to advise the government on how they can actually implement those laws. But again, what you're looking at here is that this isn't an attempt to catch anybody out. It's an attempt to look at cyber incidents that have hit and have affected production. And there is one very high profile case where a company had to purchase back 250 million of their own stock from the US government to meet supply elsewhere after a cybersecurity event. So that's the type of thing where that was a vaccine. So if you've got people all over the world where governments have agreed to distribute a vaccine to members of their population, and now the company can't give that supply, that's the risk, and that's what they're here to police. So, any of the companies in essential can expect a fine of up to 10 million or 2% of their total worldwide turnover. But anyone in the important, it's 7 million and 1.4% of total annual turnover. But it is a significant amount of money. But I think it's the fact that these things happened behind closed doors before and now they're in the open is potentially the biggest impact.
Very nice. Another question. If I'm a chemical plant, how do I find out if I'm covered under this or not? Because some plants will be and some plants won't. Is there criteria based on, if you go down, you might pollute the atmosphere?
Absolutely. And again, there's some very good guides out there. I can pass them on afterwards in terms of how you deem in scope or not in scope. But there is it's exactly like that. It's, if you're wastewater, the risk is that you'll cause pollution if you're down, or you know, something like that, or that you won't be able to deal with the product, you won't be able to deal with the wastewater that's you've agreed to. So it is there, you know, there are some guidelines on to who is scope, but in general, I would say, you know, anything that has the potential to impact a serious process would be in scope. You know, it's not a, if you look at retail, obviously quite a lot of that is out of it, but you know, for the forum that we're here today, the vast majority of what we're talking about is in scope. And you know, one of the things that a lot of people ask is, you know, how are we going to deal with this, and how does this come about? And there's a lot of similarities between what happened with health and safety back in the day, you know, where you took the Health and Safety Act of, you know, upgraded in 2005, which replaced the previous act of 1989, where now you don't dream of setting foot on a construction site without safe pass and introduction and knowing what you're doing and following the safe areas and things like that. And that's actually the guys having lunch at the Rockefeller Center build, which, you know, just goes to show, you know, where that industry was versus where it is today. And one of the very interesting things is that, you know, it's very clear now that everybody knows as an employer what your duties are in health and safety. Everybody knows as an employee what your duties are under health and safety. Penalties, you know, can my name be published? Can I get an on-the-spot fine? But, you know, in health and safety, it's very clear that the onus is locally within the organization. You know, some accident happens within your plant. It isn't good enough to say, well, we had a corporate policy that was this. You need to meet the legislation in the land for health and safety. If you're part of a multinational, the Irish laws apply to you. It isn't that we're US or we're UK or we're European that we've implemented those standards. So that's where NIS2 will become very similar to something like this, where the plant itself is going to have to take responsibility. And again, we work with a lot of US multinationals where this only applies to their EU operations. So a company that's headquartered in the US, where all of the directives come out of the US, doesn't apply to the office that they're in, doesn't apply to any of the plants near them, but it applies to everybody within the EU that's in scope of the directive. So in terms of then, how can we prepare for it, or how can you get there? And a lot of this stuff isn't just about compliance, it's about doing the right thing and protecting your manufacturing. And the first thing is you need to know your risks. So you need to define the critical processes. A lot of companies we work with, a lot of the engineers will understand what it takes to run the product. They don't know that from an IT point of view, which is, you know, very easy to say, I just need that PC to empty the tank. But without the historian system collecting that the tank was emptied or that it was filled again, it's no use, because historian needs to report that you did it, or else the batch is useless. And in a big biopharma company, you could be talking batches of $4, $5, $6 million. So, you know, you need to first of all know what your processes are and know what those risks are. Again, looking at those dependencies to say, do I have a dependency on a non-local system? So if I have a dependency on something that isn't within this four walls, and this is where, again, a lot of the AI analytics are starting to come in and say, they'll analyze your data. If I need to get to the cloud to analyze data and come back before that production process can continue, what happens if it's not available? One of the anecdotes I have for this is a big multinational that we work with had an issue December 22, where everybody was sitting at their desk and streaming the Football World Cup, which was on in Qatar. And they filled the circuit that was leaving the plant to go out to the rest of the world for them to access services. And an email went around saying, please stop streaming the football. You're stopping manufacture, you're stopping systems from being operational. If that stopped you getting on a Teams call, stopped you getting on email, stopped you getting on things like that, not the end of the world, right? You can do it from home, you can do it whatever. If that stops a critical manufacturing process from talking to a system that it's dependent on, now you're in trouble. So again, knowing those integrations, knowing the dependencies that you have on those systems is going to be critical to making sure you can continue. So controlling access and this stuff, a lot of this is part of the NIST and this 62443 in terms of, you know, who's got access to that data. In the OT world or in the control systems world, it's not always very well policed the way it is in IT, who's got access to that system. Somebody leaves the organization, did you disable their account? You know, just because somebody needs operator permissions or supervisor permissions, they may be an operator, but somewhere during the commissioning phase, we found they couldn't empty the tank unless they had supervisor permissions. A lot of time that doesn't get fixed. You just drive on through it and say, we leave everybody with supervisor permissions and we'll go on. So there is a lot of looking at those kind of systems to say, how can we make sure this is done? Nobody's expecting to retrospectively go back to a system from 10 years ago and fix that, but you put it in the design of the next upgrade that you say, there's going to be an upgrade coming for this system. Let's make sure we get it right. Every new system we bring in from now on, let's make sure we get it right. And then over time, you'll see those legacy systems going out. But, you know, like I said, none of these systems are bought for their IT capabilities. But what's brought into scope now is that their IT capabilities have to be better policed when you implement them. And more people in the process and chemical side need to understand the nuances of IT and need to understand who to go to get the correct and proper support. So training is huge, obviously huge for everybody, for the operator to say, you don't just accept a link because a guy said he was from Rockwell and you left him in, you left him at the PC, but also, you know, what are the differences between IT and OT and understanding this is the PC that empties the tank. It isn't the PC that you run your email from. If you can run your email, if you can go shopping on Amazon, if you can, that's a risk. And you need to highlight that to say, how did that happen? It shouldn't have been available in the first place. Because the risk is the tank went in and 15 years later, the same PC is still in front emptying it. You've gone through 5 different PCs on your IT side of the house with better security and better infrastructure to secure it. And again, a very good incident response plan to say, what happens if? So the day we get a cyber attack in IT, can we bring the shutters down on OT? The day we have an incident in OT, how can we make sure that we get back to manufacturing immediately? And like I mentioned earlier about, you know, the cyber guys or the hackers now are taking that data and publishing. Very important in terms of financial and retail and all of those things. In terms of OT, well, there might be some intellectual property there that isn't going to affect you from going back into production. You want to get back into production as quick as you can. So having a good detection to say we've been attacked and a good response to say, here's how we're going to recover and get ourselves back working again is critical. So just a little bit about Cyber Ireland. So Cyber Ireland is the national cybersecurity cluster, and it brings industry, academia, and government together. And they actually have started an OT security special interest group. So again, it's new, but it's something that they're actually looking for a lot of input from a lot of people in the process and chemical and industrial control system field, just in terms of, again, as a forum, how can we all get together and say, this is where the industry is, this is the right thing to do, and reach out for help to say how to do the best thing. And your exact question of who's in scope, that's the type of thing that the OT Special Interest Group will do in Cyber Ireland to say, how can we define and how can we make sure that we're being properly addressed? So there's a committee, it's headed up by Donald Cusack, who's worked for the Pew Synthes, the Johnson & Johnson company. I also sit on the committee, but it's part of that Cyber Ireland. And again, it's an initiative just to say, how can we make sure that OT in cyber is dealt with differently to IT? Because what you've seen from the presentation is that it's a completely different environment. And, you know, the challenges is, again, organizations not having a clear OT strategy, not understanding the difference between IT and OT, and not having the skills or the training or anything to actually put in a proper OT strategy. And then the goals are provide a forum for the industry, and professionals in the OT space to get together and learn from each other and say, we did this, you should do it. Excuse me, and deal with how people can address their specific OT challenges in the environment. So that's something that's definitely worth a look from everybody in the field. And again, there are people on the committee and on the panel who have a very good understanding of OT coming from the IT side, but there are also people looking to learn from groups like this and from the ISA to say, can you help me understand how I can secure my environment? And can you help me understand how I can look at taking responsibility for the NIS2 directive when it comes in for my environment? So what DataLogiX do, very quickly, our role is to be that middleman. We're not tied to any products. We're not, Rockwell, Emerson, Siemens. We deal with whatever the company has, and we'll help you apply the standards to say, here's how best to secure a system. And we can help you do that with site surveys, network design, system deployment and management, and an OT cyber architecture. And at a very, very high level, we would say, of course, you can have that 15-year-old piece of equipment connected to the network, but you certainly shouldn't leave it access to the same systems that the one you deployed a week ago has access to, so that you can have that old system online, but if it only needs historian access, let's only give it access to a historian. If the newer system needs to be collected by analytics, let's open that up to have analytics. And that's again where we fit into the field. So I think that's it. Hopefully I'm right on time, but just to summarize, a quick intro to cyber, as I said, cyber in general, and how that relates to OT, for example, different to IT. The automated manufacturing environment and how it came from digital or analog and manual to how it's now digital today. What the risk to the manufacturing process is, the upcoming regulations, and then, like you saw at a very whistle-stop tour there, what secure looks like. How can I apply that Purdue model to my system to make sure I'm there? And how can I take all of those details to make sure that my manufacturing is secured, separated from IT, and I can have taken every precaution to continue my manufacturing as best I can. So that's it. Into Q&A.
Damian, thanks very much. That was very certainly informative, and certainly it's something very pertinent in today's world, especially manufacturing and all these other industries you mentioned about. So look, I'll leave it open to the house here for any questions, and also we have online questions as well. But let's start here initially. Maybe.
Thanks very much. I had a couple of questions. One was a very basic one on ransomware. Do companies who are subjected to ransomware, if they pay it off, does the ransom company tend to give them back data, or do they tend to milk them again and again and again?
Excellent question. It's one of the things, the first time we saw ransomware, probably 15 years ago, longer, when we saw that first, we said, why would you pay? Why would you pay? What are the chances that this guy will give your data back? But what actually happened is the companies that were deploying the ransomware have a dependency on you saying, I got my data back and everything was fine. Because if you paid, the next guy's going to pay, and the next guy's going to pay. So far, if you go around the world, you'll see law enforcement agencies in the US have actually paid the criminals to get their data back. So 99 times out of 100, the data comes back. The issue is there have been situations, and one of the biggest ransomware attacks that happened in manufacturing happened as a consequence of the Russia-Ukraine conflict, where the Russians actually, they made a change to something that was, it's like a tax return system in Ukraine. People downloaded it to their PC and the ransomware went off, but there was nobody at the end of the message to say, pay the ransom. It was purely just to do as much destruction as possible. And the company I spoke about that had to buy back their own product, they actually fell victim to that. It was downloaded by somebody in their organization on the office network who was dealing with tax return, who got encrypted with ransomware, which stopped manufacturing in every single one of their pharma plants worldwide.
Thank you. In terms of time and money, a lot of the pharma industry and bio industry here is maybe 10, 20 years old, and it's fairly up to date in its equipment. What do you think is required to bring them up to the standard required, you know, time-wise and money-wise? I mean, obviously they need to be starting yesterday and all that kind of stuff, but in general, is it an ongoing thing? Is it 6 months? What is it?
It is an ongoing thing. And like I mentioned, it's something we learned over the years, is that in industrial control systems, you don't fix things overnight. You know, 24/7 operation makes it very difficult. If you get a 5-hour downtime window, that involves getting it fixed, getting it requalified, and getting it back into production with a test to say that you can go back working again. So it isn't something that you can click your fingers and fix it. But I think right now it's about standing up and taking notice and saying, I know where my risks are and I'm going to put them in. And that 20-year-old piece of equipment that you have, it's very unlikely that the tank is going to change in that analogy that I had. But the PC at the front end may change. The software it's running may change, because the one that was 20 years ago probably doesn't integrate with the analytics system that you had. So there was a business reason to do it. And it's as you go around changing those systems, can you make sure that they now comply better with the regulations, that you've given yourself a better chance? And the starting point is always going to be, what am I dependent on? And I always say to people, I have no issue with you producing on the business network. If you want to plug your most critical system into the business network and produce from there, as long as you know the risk. And once you know the risk and you're prepared to accept the downtime, no issue. And again, we see across the industry, pharma, bio is a lot different to consumer health, for example. They can potentially tolerate some downtime, but to them, it's about quantity. It's about keeping the product on the shelf. It's a different risk, but still, you know, no different in terms of what the impact to the bottom line is. But the quick answer is, you're probably talking a 5-year strategy, realistically, and you're probably talking starting today, addressing all your systems and say, how can I do my distributed control system? How can I do the vendor package equipment? How can I do the historian, the electronic batch record? How can I look at all those systems one by one to make sure that I can holistically cover the dependencies and deploy it correctly? But the single biggest risk is taking the convenient way out and deploying with a dependency on IT is what we'd see as the single biggest risk. Because if you jump on the IT system, you take all the risk that goes with that. So if the organization has a good OT strategy and you can piggyback on that, great. But again, look locally at the dependency of each system to say, what do I need to do to continue producing? And do a desktop exercise to say, what happened if I lost the business network? What happened if I lost Active Directory? What happens if I lost the network? And look at the impact of those.
Great. Okay, thanks. Just on behalf of Engineers Ireland Chemicals and Process Division, I'd just like to say a sincere thank you, Damian, for that. It was a wonderful presentation. I think you'll agree with me on a subject that, to be honest, probably not a lot of us knew a lot about. We kind of heard something about it, but we can fully understand that it's a coming concern, or it's a concern today, which is probably going to grow just the way that data is evolving, and you've explained it so well. So just a round of applause for Damian for all the work he put in, and for coming up from Cork today and all that to share his experience with us. It's been absolutely fantastic.